Hi, what you're about to see is one of a series of short films from Tier 3 Solutions in which we outline ideas, principles or techniques which are bread and butter to us but may not be so familiar to everyone. We'll take the opportunity to answer some frequently asked questions too. The films should be a bit like the grey boxes you sometimes find at the side of magazine or journal articles that explain some of the background to a thing without interrupting the flow. If there's a specific topic or question you'd like to jump to, you may be able to find it in the timeline across the bottom of the frame.
You may have heard of trail cameras or camera traps from wildlife films from the BBC or National Geographic. The principle is to use an unmanned camera in the field to detect the presence of animals. A filmmaker might use a simple camera triggered by passing animals to find out where to go with a cinema camera in order to film. Or they might use a higher quality camera, triggered by the animal itself, to film a particularly elusive or rare species. As scientists, we can make use of this technology too. We've used self-contained trail cameras in many studies. They're designed to be robust and weatherproof, and can capture short video clips or still images in daylight or at night using infrared illumination. They usually run on readily available AA batteries and write data to SD cards. Depending on the amount of activity it captures, a trail camera might be able to operate this way, unattended, for a week or so. We may use cameras like this to see how animals respond to an experimental setup. Do they prefer sunflower seeds or sugar beet seeds? Will they venture out from cover to collect mealworms? How about oilseed rape seeds? Or we can use them to monitor populations of very shy or nocturnal animals. We can spot juveniles, and this tells us that the population is successfully reproducing. The proportion of animals we see that are juvenile can give us an idea of how much breeding is going on. We may need to know whether animals forage or feed in some areas more or less than in others. In-crop versus off-crop, for example. We can use these simple trail cameras to get samples of their behaviour in different locations and compare it. For some situations, such as small bird foraging, even digital trail cameras take too long to start up and film. A small bird may flit into the frame and grab one or two seeds in less than a second. For this situation, we've used continuously recording pocket video recorders with separate bullet or lipstick cameras. Because they are recording all the time, they never miss even very brief events. We can copy the video files from our cameras to secure hard disks or laptops, and watch or decode the footage to extract the information we want. A trail camera may have recorded some falsely triggered events. These are quickly identified and discarded. Most of the events will be animal visits though, and we can watch and record what species was present, what it was doing during the video capture, and often how old it is, or how many animals of various ages were present. To extract fine details, we can play and replay an event as many times as we want. You can't do that when it's just someone observing. We can show the video clips to others, and we can retain the video as a permanent record of exactly what happened if we choose. At Tier 3, we have custom software to help us do this efficiently. Burma 2, for example, gives us a playback screen with a grid overlaid, so we can see exactly which food items a wood mouse takes and from where. But if we have to watch the video files anyway to decode them, wouldn't it be just as easy to have a biologist watching in the field in the first place? Well, no. Humans are hard to completely hide or disguise. Mammals in particular can detect them by smell. So, when there's a biologist around, the behaviour you want to monitor may not happen because they are around. Also, some events are quite rare. Once we have bought and set up a camera, using it to look out for unusual events entails minimal further cost. It's expensive to pay a biologist to sit and watch for hours, days or weeks when not much happens. It's far more efficient to have her watch only the events of interest without having to wait for them. And she can do that from a comfy chair indoors. There are situations when an automatic camera like this can't be used. Scan sampling studies, for example, where we quantify bird behaviour on a whole field, can't be done automatically. The observer often needs to use binoculars, or, on larger fields, a high-powered telescope, to identify birds and see what they're doing. And they need to scan their telescope across a flock of birds. An automatic camera can't do this, so it still requires someone to spend time observing in the field. There is a cost to buying and maintaining this equipment, of course, but it allows us to gather much, much more data than we could by just watching ourselves. And this more than offsets the additional startup cost.